Hi and Assalamualaikum. My name is Amirul Mustaqim bin Azhar. My matrix number is B1323103002. Today I'm going to discuss about our lab that we chose out for our assignment, which is bearing friction analysis in sliding and rolling bearings. This is our group members. The first one is Akmal Hafid bin Zulkifli, and then Amirul Mustaqim bin Azhar, which is me myself, and then Asfa bin Ahmad, and lastly Chin Kahin. I'm going to talk about the objectives of this experiment. The first one is to determine the coefficient of sliding friction for different bearing types, and then to compare friction performance between slide and roller bearings. That's it from me. Thank you.
My name Akmal Rafi bin Zulkifli. My matrix number B1323100130. I'm gonna discuss about the methodology. So for the setup, three types of bearing were installed, namely roller bearings, groove ball bearings, and slide bearing. The slide bearing use different material combination, which are gunmetal steel, PTFE steel, and G25 steel. So next for the parameters, propulsion mass was added incrementally in step of 1 Newton using a cable drum system. The system was carefully observed to determine the exact point when rotation began. Lastly, during the friction test, the force required to initiate movement was measured. Based on this measurement, the coefficient of sliding bearing type was calculated. We go to types of bearing used. So in this study, several types of bearing were used to observe difference in frictional behavior. According to Navarro Jimenez, ET 2080, the friction performance of bearings may vary due to surface roughness and material deformation at the contact area. These factors interfere with smooth motion and lead to increased resistance. And the bearings selected for testing include roller bearings, specifically groove ball bearing, and three types of slide bearings made from different material, such as gunmetal steel, PTFE steel, and GG25 steel. These types allow for different materials effect frictional characteristic.
Good morning, everyone. My name is Chingahin, and I am right now to handle the chapter of result and discussion. So, for the start, based on our result presented, different bearing material exhibit significantly vary performance in terms of propulsion mass and coefficient friction. Among the test types, the roller of groove ball bearing show the best performance, requiring only 3 Newton of propulsion mass and demonstrating the lowest coefficient of sliding force at 0.0210. This indicates the excellent efficiency due to minimal friction, making it highly suitable for applications where smooth motion and energy efficiency are critical. In real-life scenarios, such bearings are commonly used in bicycle, electric motors, skateboards, and fans, where low resistance and high-speed performance were desired. On the other hand, slide bearings, especially those made of gunmetal steel, PTFE steel, and G25 steel, require significantly higher propulsion mass of 9 Newton, 8 Newton, and 10 Newton respectively. With corresponding higher coefficient of friction, the PTFE steel slide bearing perform a better among the slide bearing group. With a coefficient of 0.1628 and slightly lower propulsion mass. This max is a good option for environment that demand corrosion resistance and minimal maintenance, such as food processing and chemical plants. Although it is less suitable for high load applications due to its softer polymer materials, gunmetal steel slide bearings with a coefficient of 0.1824 undurable, and higher friction lead to more energy loss. The 3G35 steel bearing shows the highest friction, which is 0.201 and propulsion mass with 10 Newton, which limit its use to heavy-duty application where robustness is prioritized over efficiency, such as automotive component or heavy machinery. So in summary, while Laurel bearing offer the best performance in terms of low friction and propulsion efficiency, slide bearing, particularly PTFE steel, can be suitable alternative in specific application, where conditions like chemical exposure or heavy load bearing are more critical than energy efficiency. Thank you.
Assalamualaikum and good evening. My name is Asfar Ahmad, number metric B13231028 and I'm going to present about the last part of the bearing friction analysis slide and rolling bearing, which is the conclusion. So the conclusion is from the experiment, uh, while comparing roller and slide bearing, the roller showed significantly less efficient, making it more efficient in reducing friction. But among the slide bearing, with the three comparison, the PTFE still had the best performance with lower sliding friction, indicating that it's the most suitable material for minimizing wear. Uh, Friction varies significantly with bearing type and materials. Rolling bearing experience less resistance due to rolling contact, while slide bearing affected by surface interaction and material properties. That is all from our group. Thank you.